Artificial intelligence is rapidly transforming various industries and impacting society in profound ways. At the core of AI are algorithms that allow machines to perform tasks that typically require human intelligence. In this episode, we will dive deeper into the world of AI algorithms, exploring the different types of algorithms, how they work, and their potential power to transform industries. While AI algorithms hold great promise, they also have inherent limitations that we will discuss. Moreover, AI is not without its ethical concerns, and one of the critical issues that we will highlight is the importance of algorithm bias and fairness. So join us as we explore the power and limitations of AI algorithms and the implications for the future of technology and society. AI algorithms are a series of instructions or rules that enable machines to learn from data and make decisions. These algorithms are the core components of artificial intelligence systems, and they can be used to perform a wide range of tasks. AI algorithms are designed to work by analyzing data and learning from patterns and trends within that data. Once they have learned from the data, they can use that knowledge to make predictions, recommendations, or decisions. The goal of AI algorithms is to automate complex tasks that would otherwise require human intelligence and decision-making. By doing so, they can help to increase efficiency and productivity, reduce costs, and improve the accuracy of decision-making in a variety of industries. Supervised learning is one of the most popular types of AI algorithms, where an algorithm is trained on a labeled dataset to predict an output based on certain inputs. This algorithm is provided with data and corresponding outputs to learn from and improve its accuracy in making predictions. Unsupervised learning, on the other hand, deals with unlabeled data and relies on the algorithm to identify patterns or relationships within the data. It is used to discover hidden structures within data and find clusters of similar data points. Reinforcement learning is a type of AI algorithm that involves learning through trial and error. The algorithm receives feedback in the form of rewards and punishments based on its actions, allowing it to learn which actions are beneficial and which are not. Deep learning algorithms are modeled after the human brain and use neural networks to learn and make predictions. These algorithms are used for complex tasks such as image and speech recognition, natural language processing, and self-driving cars. They can process vast amounts of data and identify patterns that are not immediately apparent to humans. In order to work, AI algorithms require large amounts of data to be inputted into the system. This data is typically preprocessed and transformed into a format that the algorithm can understand. Once the data is ready, the algorithm is trained on the data through a process of trial and error. During the training process, the algorithm makes predictions and receives feedback on the accuracy of those predictions. The algorithm uses this feedback to adjust its internal parameters and improve its performance. Once the training is complete, the algorithm can be used to make predictions or decisions based on new data. This process is known as inference. The accuracy and effectiveness of the algorithm depend on the quality and quantity of the data used for training. The more high-quality data an algorithm has access to, the better its performance is likely to be. AI algorithms have the power to analyze vast amounts of data in real time, enabling organizations to make data-driven decisions. For instance, in healthcare, AI algorithms can analyze patient data to provide more accurate diagnoses and treatment recommendations. In finance, AI algorithms can help identify fraudulent transactions, manage investment portfolios, and automate customer service. In manufacturing, AI algorithms can optimize the production process, predict equipment failures, and improve product quality. The power of AI algorithms lies in their ability to process and analyze vast amounts of data quickly and accurately, providing insights and solutions that were previously impossible. Another limitation of AI algorithms is their lack of common sense, meaning that they may not be able to reason or make decisions in situations where there is no clear answer or where context plays an important role. AI algorithms may also struggle to handle complex or ambiguous situations, and they may be vulnerable to cyber attacks or adversarial attacks where malicious actors deliberately try to deceive or manipulate the algorithm. Furthermore, the implementation of AI algorithms can be expensive, and the lack of regulatory frameworks can make it difficult to ensure the ethical use of these technologies. To overcome the limitations of AI algorithms, researchers and developers can employ several techniques. One of the key techniques is to ensure that the algorithms are transparent, explainable, and free from bias. This involves using diverse and representative data sets to train the algorithms, ensuring that the algorithms are accountable and can provide clear explanations for their decisions. Developers can also employ techniques such as transfer learning, which involves using pre-trained models to improve the accuracy and efficiency of new models. Continuous monitoring and updating of AI algorithms can also help to ensure their accuracy and effectiveness. Finally, it is important to recognize that AI algorithms are not a replacement for human decision-making, and that human oversight and intervention are still necessary in many cases to ensure the best outcomes. Unsupervised learning is an area of AI research that involves training algorithms on unlabeled data. This can help AI systems learn more complex and abstract relationships within the data, leading to more accurate predictions and decisions. In terms of neural networks, researchers are working on developing more sophisticated architectures that can handle even more complex tasks. This includes the development of recurrent neural networks, which can process sequences of data, and convolutional neural networks, which are optimized for image recognition tasks. Natural language processing is also a rapidly developing area, with the potential to transform the way we interact with machines and automate tasks in various industries. Algorithm bias and fairness are important because AI algorithms can perpetuate and amplify existing biases and inequalities in society. For example, if an algorithm is trained on data that is biased against a particular group, such as women or people of color, it may produce biased outcomes. This can lead to unfair and discriminatory decision-making that can harm individuals and communities. To address algorithm bias and fairness, developers must carefully consider the data used to train their algorithms and ensure that it is diverse and representative of the population. They must also implement fairness metrics and test their algorithms for potential biases before deploying them in real-world applications. Additionally, developers must involve a diverse set of stakeholders, including members of affected communities, in the design and development of AI algorithms to ensure that they are fair and equitable. And that concludes our discussion on the power and limitations of AI algorithms. As we've seen, AI algorithms have the potential to transform various industries, but they also have limitations and biases that must be addressed. In our next episode, we will explore the role of AI in the future of transportation, including self-driving cars and smart traffic management systems. Join us then for another exciting episode.